The darkness out here is absolute. We're drifting now, somewhere beyond the orbit of Mars, in the space between worlds where sunlight arrives thin and cold. Tonight we're traveling slowly outward, past the asteroid belt, toward the realm of Jupiter and its family of icy moons. There's no hurry. Just distance and time and the quiet motion of our path through the void. The sun behind us is smaller than you might expect. Not the blazing disk you know from Earth, but a bright star, fierce and distant. It still gives light, still gives warmth of a kind, but out here that warmth is a memory, a whisper of what it means closer to home. The cold is patient. It doesn't press against you. It simply is, has always been, will always be. This is the temperature of deep space, the natural state of the universe in all the places where stars do not reach. We're moving at a steady pace, though there's nothing nearby to measure our motion against. No landmarks. No reference points. Just the slow shift of stars across the black, and ahead, still weeks away at this speed, the presence of something vast. You can't see it yet, not really, but it's there. A gravitational weight in the fabric of space. A disturbance. A king planet holding court in the outer system, surrounded by its moons. Jupiter. The name feels large even in thought. It's the giant of our solar system, the planet that might have become a star if only it had gathered more mass in those early days when the solar system was forming. It didn't. It became something else instead. A world of gas and storm, 11 times wider than Earth, 318 times more massive, spinning fast in the cold dark, pulling everything nearby into its orbit. Moons. Rings. Dust. Radiation. All of it held in place by gravity's patient hand. But we're not going to Jupiter itself. Not tonight. Tonight we're interested in what circles it. The moons. Especially the ones made of ice. Ice is common out here. Beyond a certain distance from the sun, beyond what scientists call the frost line, water doesn't evaporate. It freezes, stays frozen, accumulates. Out here, ice is as much a building material as rock. Maybe more so. The moons of Jupiter, the ones we're approaching now, are worlds where ice runs deep. Shells of it. Oceans of it hidden beneath frozen surfaces. Ancient ice, layered and cracked and shaped by billions of years of time and pressure and the relentless pull of Jupiter's gravity. There are dozens of moons around Jupiter. We've counted at least 79, and there may be more, small irregular fragments captured from the asteroid belt or born in the chaos of the early solar system. But 4 of them stand out. 4 large moons, visible even from Earth with simple telescopes. Galileo saw them first in 1610, and they carry his name now. The Galilean moons. Io, Europa, Ganymede, Callisto. Each one a world unto itself. Each one different from the others, shaped by its distance from Jupiter, by the forces acting on it, by the accidents of its formation. Io is the closest, but Io is not our focus tonight. Io is volcanic, furious with heat, its surface constantly remade by eruptions and lava flows. No ice there. The tidal forces from Jupiter and the other moons squeeze Io like a hand squeezing a rubber ball, generating heat, keeping it molten. It's a world of fire in a realm of ice, and it's an exception. The other 3, though. Europa, Ganymede, Callisto. These are ice worlds. Frozen, patient, quiet. And they hold secrets. We're still far out. Millions of miles to go. But we can start to feel the shape of the system now, the way the gravity curves space here, the way everything moves in rhythm. The Galilean moons orbit Jupiter in a pattern, a resonance. For every orbit Ganymede makes, Europa makes exactly 2, and Io makes exactly 4. They're locked together, dancing, their positions repeating in an endless cycle that has continued for billions of years. It's a pattern born from gravity, from the way these worlds tug on each other, settling into a configuration that's stable, predictable, eternal. The closer you get to Jupiter, the stronger the tides. Gravity isn't uniform. The side of a moon facing Jupiter feels a stronger pull than the side facing away. This difference, this gradient, stretches the moon slightly. And because the moon is orbiting, because it's moving, this stretching changes direction, flexing the moon's interior, generating friction, generating heat. It's a subtle process, but it's enough. Enough to keep water liquid beneath miles of ice. Enough to drive geological processes that would otherwise have frozen solid billions of years ago. This is the secret of Jupiter's icy moons. They're not dead, frozen relics. They're active in their quiet way. There's movement inside them. Circulation. Change. Processes unfolding in the deep darkness beneath those ice shells, processes we're only beginning to understand. Time passes differently out here. The distances are so vast that weeks blur together. Our approach continues, steady and slow. Jupiter grows brighter ahead, a point of light that gradually, imperceptibly, begins to show a shape. Disk. Presence. The stars around it shift slightly as we draw nearer, parallax revealing depth where before there was only flatness. And now, finally, we can begin to see the moons themselves. Not as disks yet. Not as worlds. Just as points of light, moving against the background of stars, tracing their orbits around that bright central point that is Jupiter. For lights, steady and calm, each at a different distance, each following its own path. From here they look fragile, delicate, like fireflies in a vast dark garden. But they're not fragile. They're enormous, each one thousands of miles across, each one ancient beyond imagining. We're crossing into Jupiter's realm now. There's no border, no boundary line, but you can sense the change. This is Jupiter's space. Its gravity dominates here. The sun still provides light, but Jupiter provides order. Structure. The orbits of everything nearby bend around it, acknowledge it, respond to its presence. We're entering a miniature solar system, a king planet and its core of moons, isolated out here in the cold reaches beyond Mars, beyond the asteroid belt, in the outer system where ice and rock are the materials of world building. Jupiter itself is beginning to resolve. Still far away, but no longer a point. A sphere. Bands of color, faint but visible. The Great Red Spot, a storm larger than Earth, spinning in the southern hemisphere, a feature that has persisted for centuries at least, possibly far longer. The planet rotates fast, just under 10 hours for a full day, making it oblate, slightly flattened at the poles, bulging at the equator. Cloud tops race past, churning, mixing, separating into zones and belts, lighter and darker bands stacked across the atmosphere. Winds blow at hundreds of miles per hour. Storms larger than worlds rise and fall and rise again. It's chaos up close, but from here, from this distance, it looks almost peaceful. Stately. A massive presence, holding its ground in the darkness, anchored by its own enormous mass. But we're not stopping at Jupiter. We're passing it, moving toward the moons, into the orbital spaces where the ice worlds circle. The radiation here is intense. Jupiter has powerful magnetic fields, trapping charged particles, creating belts of radiation that would be lethal to unprotected human tissue. The inner moons, especially Io and Europa, orbit within these radiation belts, constantly bathed in high-energy particles. It's a harsh environment, but the moons endure. They've endured for billions of years. Ice can be remarkably resilient. The dance of the moons becomes clearer now. We can see their positions relative to each other, relative to Jupiter. Io, closest in, sulfur yellow and orange with its volcanic surface. Then Europa, pale and bright, reflective, the smoothest body in the solar system. Then Ganymede, the giant, larger than the planet Mercury, dark and bright terrain mixed across its surface. And finally Callisto, farthest out, ancient and cratered, a record of impact stretching back to the solar system's beginning. We're approaching Europa first. It's the second moon out, orbiting at a distance of about 417,000 miles from Jupiter's center. Its orbit takes 3.5 days. The moon is tidally locked, always showing the same face to Jupiter, just as our own moon shows the same face to Earth. One side always faces the planet, one side always faces away, and the terminator, the line between day and night, creeps slowly around the moon as it orbits, daylight lasting almost 2 Earth days before darkness returns. Europa grows larger. We're close enough now to see it as a disk, a small pale circle against the black. The color is white, or nearly white, with hints of brown and red streaking across it in lines and bands. The surface is bright, reflective, catching what little sunlight reaches this far out and bouncing it back. Ice. Water ice. Almost pure. This is a moon covered in frozen ocean, and as we approach, the details begin to emerge. The surface is strange. Smooth in some places, almost unnaturally smooth, as if polished. But elsewhere it's broken, fractured, marked by long cracks and ridges that curve across the landscape in patterns that seem almost deliberate. There are very few craters. That's unusual. Most moons and planets in the solar system are heavily cratered from billions of years of impacts. But Europa's surface is young, geologically speaking. Perhaps only 20 to 180 million years old in places. Something has erased the old craters. Something has resurfaced this moon over and over, covering the scars of ancient impacts with fresh ice. We're descending now, falling gently toward Europa, watching the surface rise to meet us. The ice shell is thick. Estimates suggest anywhere from 10 to 15 miles deep, maybe more in places, maybe less in others. But beneath that shell, beneath miles of frozen water, there's an ocean. A global ocean. Liquid water, kept warm by tidal heating, by the constant flexing of Europa's interior as it orbits Jupiter and responds to the gravitational tugs of the other moons. The ice here tells a story, if you know how to read it. The surface is marked by features scientists call Lineae, from the Latin word for lines. Long cracks, sometimes hundreds of miles long, running across the ice in every direction. Some are dark, filled with material that welled up from below when the crack first formed. Others are ridges, raised features where ice has been pushed upward along the fracture line. The patterns are complex, overlapping, suggesting multiple episodes of cracking and refreezing, a surface that has been reworked many times. There's a region called Connemara Chaos, named after a landscape in Ireland. Here the surface has broken into blocks, ice rafts that have shifted and rotated and refrozen in new positions. It looks like sea ice on Earth after a storm, when the frozen surface breaks apart and the pieces drift and jostle before freezing solid again. That's not far from what happened here, except the sea beneath is covered by miles of ice shell, and the forces breaking the surface are tidal stresses, not wind or waves. The ice is not static. It moves, slowly, on timescales of thousands or millions of years. The shell itself may be convecting in places, warmer ice from below rising toward the surface, cooler ice sinking back down. Or the ocean beneath may be interacting directly with the shell, melting it from below, allowing water to intrude into cracks, refreezing in new configurations. The exact mechanisms are still debated, still uncertain, but the evidence is clear. This surface is young, active, renewed. Beneath our position, miles down, the ocean waits. We can't see it from here, can't sense it directly, but we know it's there. The evidence comes from multiple sources. The way Europa interacts with Jupiter's magnetic field suggests a layer of conductive material beneath the surface, and salt water conducts electricity. The surface features, the chaos regions and Lineae, are best explained by a subsurface ocean. And the tidal heating calculations show that Europa's interior should generate enough warmth to keep water liquid despite the cold. The ocean is deep. Perhaps 60 miles deep, perhaps more. That's more than 6 times the average depth of Earth's oceans. The volume of water in Europa's ocean may be twice the volume of all the water on Earth. All of it hidden beneath this frozen shell, dark and cold and still, never touched by sunlight, never exposed to the vacuum of space. The bottom of that ocean, if we could travel there, would be rock. Europa has a rocky core beneath the water, differentiated from the ice by gravity, denser materials sinking to the center during the moon's formation. And where that rock meets the water, there may be hydrothermal vents similar to the ones found in Earth's deep oceans. Hot water, heated by the moon's interior, percolating up through cracks in the rock, carrying dissolved minerals, creating chemistry, creating energy gradients. On Earth, life thrives around hydrothermal vents, entire ecosystems sustained by chemical energy rather than sunlight. Could the same be true here? Could something be living in Europa's ocean, in the darkness, in the cold, in the deep? We don't know. There's no evidence yet. But the question is there, quiet and patient, waiting. Europa is one of the most promising places in the solar system to search for life beyond Earth, not because we've seen any signs of it, but because the conditions seem right. Liquid water, energy sources, organic chemistry, time. Billions of years of time for something, anything, to begin. The surface stretches out in all directions, curved away from us by Europa's small horizon. The moon is smaller than Earth's moon, about 1,900 miles across, roughly the size of Earth's moon but less massive, with lower gravity. If you stood here, if you could stand on this ice, you'd weigh only 13% of what you weigh on Earth. You could jump high, almost fly, but the cold would kill you in moments. The radiation would damage your cells even through a spacesuit. And the silence would be absolute. No air, no sound, just you and the ice and the distant sun and Jupiter, always Jupiter, hanging huge in the black sky, never rising or setting, always in the same position because Europa is tidally locked. Jupiter from Europa would be a sight beyond words. The planet would appear 11 times wider than the moon appears from Earth, covering a vast arc of sky, bands and zones and storms visible even to the naked eye. And the planet would go through phases, like the moon does from Earth, lit by the distant sun, waxing and waning as Europa orbits. New Jupiter, crescent Jupiter, full Jupiter, a calendar in the sky marking the passage of days. And sometimes, rarely, Europa's shadow would cross Jupiter's face, a small dark spot transiting the giant planet, Europa's own eclipse visible from its surface if you knew where to look. The other moons would be visible too, points of light moving slowly against the stars. Io, bright and close, occasionally passing in front of Jupiter or behind it. Ganymede and Callisto, farther out, moving more slowly through their orbits. A sky full of worlds, a miniature solar system playing out above you as you stood on that frozen surface. But no one stands there now. No one has ever stood there. Europa remains untouched, pristine, waiting. We're lifting away now, rising back above the surface, gaining altitude, watching the ice fall away beneath us. The Lineae become visible again as patterns, the chaos regions as scattered disruptions in the otherwise smooth surface. From this height, Europa looks peaceful, serene, a pale sphere hanging against the dark, reflecting sunlight, keeping its secrets locked beneath that frozen shell. Our path takes us outward now, away from Europa, into the space between orbits. Jupiter remains to one side, massive and bright, its cloud tops churning in silence. The stars are steady beyond it. And ahead, growing slowly brighter, is the next moon. Ganymede, the largest moon in the solar system. A world of ice and rock on a scale unlike anything else orbiting any planet. The distance between Europa and Ganymede is about 220,000 miles, give or take. It takes time to cross, time to drift, time to watch Europa shrink behind us and Ganymede grow ahead. The silence continues, unbroken, perfect. This is the natural state of space. Not empty, not quite, but vast beyond measure, each object separated from the next by distances that dwarf the objects themselves. Moons the size of small planets, and yet they seem like islands, isolated, each floating in its own sphere of emptiness. Ganymede resolves slowly. At first it's just brightness, a steady point of light. Then a disk, small and round. Then larger, details beginning to emerge. The color is different from Europa. Darker in places, with patches of brighter terrain mixed in. The surface has a mottled appearance, light and dark regions interspersed, like continents and oceans on a world where both are made of ice. This moon is enormous. 3,200 miles across. Larger than the planet Mercury, though not as massive because it's made of less dense materials. About half ice, half rock, differentiated into layers. An iron core at the center, perhaps, surrounded by a rocky mantle, then a thick shell of ice and water, and finally the surface we're approaching now. Ganymede has enough mass and size that it has its own magnetic field, the only moon in the solar system with one. That field is generated by a liquid iron core moving, convecting, creating magnetism the same way Earth's core does, though on a smaller scale. The orbit here is farther from Jupiter. Ganymede circles at a distance of about 665,000 miles, taking just over 7 days to complete one orbit. The tidal forces are weaker here than at Europa, but they're still present, still squeezing and flexing the moon's interior, still generating heat. Ganymede also has a subsurface ocean, buried beneath perhaps 100 miles of ice. Deeper than Europa's ocean, harder to reach, but they're nonetheless another hidden sea in the darkness. We're descending toward the surface, falling gently through the thin wisp of Ganymede's exosphere. It's not an atmosphere, not really, just a sparse scattering of oxygen molecules knocked loose from the ice by radiation impacts. The density is so low it might as well be vacuum. No air, no wind, no weather. Just the ice below and the stars above and the steady pull of gravity, weak but patient, drawing us down. The surface is ancient in places, young in others. The dark regions, called regions, are heavily cratered, scarred by billions of years of impacts. These are the oldest terrains on Ganymede, dating back perhaps 4 billion years to the early solar system when impacts were common, when the planets were still clearing their orbital paths of debris. The dark material is older ice, perhaps mixed with rock dust, darkened by radiation over eons. It's rough, chaotic, marked by craters large and small, overlapping in places, creating a palimpsest of impacts written across the surface. But then there are the bright regions. These are younger, much younger, perhaps only 1 billion or 2 billion years old. They're called Sulci, and they're characterized by parallel grooves and ridges, tectonic features where the ice has been stretched and fractured and pushed up into long linear ridges. The bright terrain covers about 60% of Ganymede's surface, suggesting that at some point in the moon's history, perhaps multiple points, the surface underwent massive tectonic activity, resurfacing large areas, erasing old craters, creating new features. The transition between dark and bright terrain is striking when you see it up close. The old, dark, cratered surface gives way abruptly to bright grooved terrain, as if someone drew a line and said, "Here the old world ends, here the new begins." The forces that created this are still debated. Tidal heating, perhaps, warming the interior enough to make the ice shell mobile, allowing it to crack and flow and reform. Or impacts, large enough to trigger global resurfacing. Or some combination, multiple processes acting over billions of years, each leaving its mark. Ganymede is quiet now. The tectonic activity has ceased, or at least slowed to the point of invisibility on human timescales. The surface is stable, cold, frozen solid. But the evidence of past activity is everywhere, written in the landscape, preserved in ice that remembers the stresses that shaped it. We're gliding over the grooved terrain now, following one of the sulci as it curves across the surface. The ridges are parallel, spaced evenly, running for hundreds of miles before fading or being cut off by another set of ridges at a different angle. It's like looking at waves frozen in ice, which in a sense is exactly what they are. Waves in the solid surface, tectonic waves, created by forces from below and preserved forever in the cold. The craters here are fewer, smaller, but they're present. Even young surfaces accumulate impacts over time. Some craters have bright rays extending from them, ejecta thrown out by the impact, fresh ice excavated from below and scattered across the darker surface. These are the youngest features, impacts that happened perhaps only a few million years ago, recent enough that the rays haven't been darkened by radiation yet. Jupiter is visible from here, smaller than it appears from Europa, but still large, still dominant. Ganymede's orbit takes it farther out, into regions where Jupiter's radiation belts are weaker, where the environment is slightly less harsh. But the planet is always there, always visible from the Jupiter-facing hemisphere, always exerting its influence through gravity, through tides, through the simple fact of its enormous presence. The stars beyond Jupiter are the same stars visible from Earth, but the constellations are only slightly shifted. We're still in the solar system, still close enough to the sun that the perspective hasn't changed much. Orion would still look like Orion. The Big Dipper would still be recognizable. Only the positions of the planets would be different, and the addition of Jupiter itself as a bright object in the sky, and the presence of the other Galilean moons visible as steady points of light moving against the background stars. Ganymede has a history, a story written in its surface. It formed 4.5 billion years ago, along with Jupiter and the other moons, from the disk of gas and dust that surrounded the young planet. It accreted mass, grew, differentiated into layers as heavier materials sank to the center. It was bombarded by impacts in the early solar system, its surface cratered and scarred. Then, at some point or perhaps multiple points, it underwent tectonic resurfacing, creating the bright groove terrain, erasing billions of years of impact history in those regions. And then it quieted, cooled, settled into the state we see now, a world caught between ancient and young, carrying evidence of both. Beneath the surface, miles down, the ocean waits. Like Europa, Ganymede has liquid water hidden beneath its ice shell. The ocean may be sandwiched between layers of ice, exotic high-pressure ice forms that exist only in conditions like this, where pressures are immense and temperatures are just right. The ocean itself might be tens of miles thick, a vast dark sea, never touched by light, held in place by the ice above and the ice below, circulating slowly, driven by whatever heat escapes from the rocky interior. Does anything live there? The same question we asked about Europa applies here. Liquid water, chemical energy, time. The ingredients are present. But the ocean is buried so deep, so isolated, that it's hard to imagine how life could begin or sustain itself. Hard, but not impossible. Life is tenacious. On Earth it exists in the deepest oceans, in the hottest springs, in the coldest ice, in solid rock miles beneath the surface. If life can exist in those places, why not here? We don't know. We can only wonder and drift and observe and wait for the day when we might be able to send a probe beneath the ice, into the ocean, to see what's there. That day is not today. Today we're only passing through, visitors, observers, traveling slowly through this system of ice and rock and hidden seas. The surface continues below us, dark and bright terrain alternating, craters scattered across both, a landscape shaped by time and force and the patient physics of ice. Ganymede is massive enough that its horizon curves away more gently than Europa's, but still it curves, reminding us that this is a sphere, a world, hanging in space, rotating slowly, once every 7 days as it orbits Jupiter, tidally locked, one face always toward the planet, the other always away. We're rising again, leaving Ganymede behind, climbing back into the space between moons. The surface falls away, the details blur, the moon becomes a sphere again, then a disk, then a bright point slowly shrinking. Our path takes us farther out now, away from Jupiter, into the colder reaches of the Galilean system, toward the last of the large moons. Callisto waits there, patient and ancient, the most distant of the four, the least changed, a record of the solar system's earliest days preserved in ice. The space between Ganymede and Callisto is vast. Nearly 500,000 miles separate these two moons, a gulf that takes time to cross even in imagination. We drift outward, away from Jupiter's inner realm, into regions where the planet's influence is still dominant but less intense, where the radiation is weaker, where the tidal forces are gentler. Out here, things change more slowly. Time moves at its own pace, unhurried, unconcerned with the briefness of human attention. Jupiter is smaller now from this distance, though still the brightest object in the sky besides the sun. The cloud bands are harder to make out, the great red spot barely visible, but the planet's presence remains. It's the anchor of this system, the gravitational center around which everything else revolves. Even out here, at Callisto's distance, Jupiter's gravity is what holds the moon in place, what has held it for billions of years, what will continue to hold it for billions more. Callisto is approaching. It's been visible for a while as a point of light, steady and dim compared to the others, but now it's beginning to resolve, to show shape and size. The color is darker than Europa or Ganymede. Where those moons were bright, reflective, Callisto is subdued, almost gray, the darkest of the 4 Galilean moons. The surface has a worn appearance even from this distance, ancient, untouched by the processes that renew Europa and Ganymede. This is an old world, and it looks old. Callisto orbits at a distance of about 1,200,000 miles from Jupiter's center. Its orbit takes 16.5 days to complete. The moon is large, nearly 3,000 miles across, almost the same size as Mercury, but like Ganymede it's less massive due to its composition. Ice and rock, mixed together, not fully differentiated. Callisto may have a small rocky core, but it's not as clearly separated into layers as Ganymede is. It's more mixed, more primitive, as if it never fully completed the process of formation that the other moons went through. The distance from Jupiter has consequences. Callisto orbits outside the strongest radiation belts, in a region where the environment is less harsh than a Europa or even Ganymede. The tidal forces here are much weaker. Jupiter's gravity still pulls on Callisto, still shapes its orbit, but the squeezing and stretching that generates heat in the inner moons is minimal here. Callisto is cold. Its interior may have never melted completely, never differentiated fully, never generated the warmth needed to drive tectonic activity or maintain a liquid ocean, at least not one as clearly defined as Europa's or Ganymede's. We're descending now, falling toward the surface, watching the details emerge. And the details are striking in their uniformity. Craters. Everywhere, craters. Small ones, large ones, overlapping ones, fresh ones, ancient ones worn smooth by billions of years of micrometeorite bombardment. Callisto has the most heavily cratered surface in the solar system, a landscape that has remained largely unchanged for 4 billion years or more. Where Europa's surface is young and Ganymede's is mixed, Callisto's surface is ancient, a record of impacts stretching back to the solar system's violent beginning. The craters are bright against the darker background, excavating fresher ice from beneath the radiation-darkened surface layer. Some have central peaks, features formed when the center of the crater rebounds after impact, the ice flowing briefly like liquid before refreezing. Others have terraced walls, concentric rings where the impact structure has slumped and settled. The largest craters are visible even from high altitude, enormous scars hundreds of miles across, their rims casting shadows across the surrounding terrain. There's one crater in particular, a feature so large it has its own name. Valhalla. It's not just a crater but a multi-ring impact basin, the result of an ancient collision with an object perhaps tens of miles across. The impact created a central bright spot about 370 miles across, surrounded by concentric rings that extend outward for hundreds of miles more, perhaps 1,200 miles in diameter for the entire structure. The rings are fractures in the ice, places where the shock wave from the impact propagated through Callisto's surface, cracking it, creating these circular patterns that radiate outward from the center. Valhalla is old. The exact age is uncertain, but it formed billions of years ago, back when the solar system was still young, when impacts of that scale were more common. The structure has been worn down over time, softened by the slow relaxation of ice under its own weight, by the constant rain of smaller impacts, by radiation darkening the surface. But it's still there, still visible, still the dominant feature on this side of Callisto, a scar that will remain for as long as Callisto exists. We're gliding over the surface now, low enough to see individual craters in detail. The ice here is ancient, darkened by billions of years of exposure to Jupiter's radiation and to cosmic rays from beyond the solar system. Radiation breaks down the molecular structure of ice over time, darkening it, mixing it with whatever organic compounds and dust particles happen to be present. The result is a surface that's darker than pure ice, almost gray in some places, brown in others, a patina of age covering everything. But wherever a fresh crater has formed, the ice beneath is brighter, cleaner, less affected by radiation. The contrast creates a mottled appearance, bright splashes scattered across a dark canvas, each bright spot marking where something from space has punched through the surface layer and exposed the fresher ice below. Over time, even these bright spots will darken, will match the surrounding terrain, will blend in. But new impacts will continue to expose fresh ice, will continue the cycle that has been ongoing for billions of years. The surface is not entirely flat. There are subtle variations in elevation, the rims of craters standing higher than the surrounding plains, the floors of craters sometimes lower, sometimes filled with material that flowed in after the impact. But there are no mountains in the sense Earth has mountains. No tectonic uplift, no volcanic cones, no sharp peaks. Just craters and the gentle undulations they create, a landscape worn down by time into something almost smooth despite the violence that created it. Callisto is quiet. More quiet than Europa, more quiet than Ganymede. There's no tectonic activity here, no resurfacing, no grooved terrain, no chaos regions. The ice shell is thick, stable, frozen solid perhaps all the way down, or if there's liquid water beneath, it's buried so deep, under so much pressure, that it might as well not exist for any practical purpose. This is a world where change happens slowly, where the only events are impacts, and impacts are rare on human timescales, and even on geological timescales they're infrequent enough now that the surface can remain stable for billions of years. Yet there's a beauty to this stability, this anciency. Callisto is a time capsule. Its surface preserves a record of the early solar system, of the era of heavy bombardment when the planets and moons were still being pelted by the debris left over from their formation. Most worlds have lost that record, have resurfaced themselves through volcanism or tectonics or erosion. But Callisto has not. Its surface is a library, written in craters, telling stories of impacts that happened when the solar system was young, when Earth itself was still being shaped by similar collisions. The inner moons, the ones that orbit closer to Jupiter than Io, are different from the outer irregular satellites. These are part of the original system, born from the disk of material that surrounded Jupiter as it formed. They're small, but they're aligned with Jupiter's equator, orbiting in neat circular paths, moving in the same direction as the planet's rotation. They're embedded in Jupiter's rings, faint gossamer structures made of dust particles kicked up by micrometeorite impacts on the moon's surfaces. Métis and Evrysdia are the innermost, orbiting just above Jupiter's cloud tops, inside the orbit of Io, racing around the planet every 7 hours. They're tiny, irregular chunks of rock and ice only a few miles across. The environment there is harsh beyond measure, deep within Jupiter's radiation belts, bombarded constantly by high-energy particles. Nothing could survive there. Even robotic spacecraft have difficulty in those conditions. The Galileo probe that studied Jupiter in the late 1990s had its electronics degraded by the radiation, its mission shortened by the relentless assault of charged particles trapped in Jupiter's magnetic field. Amalthea is slightly larger, about 100 miles across at its longest dimension, potato-shaped, dark red in color. It orbits farther out than Métis and Evrysdia, but still well inside Io's orbit, taking 12 hours to circle Jupiter. Amalthea is thought to be a rubble pile, a collection of fragments held together by its own weak gravity, porous, full of voids and empty spaces. Impacts over billions of years have shattered and reshattered it, but it endures, held in its orbit, continuing its endless circuit. Thebe is the outermost of the inner small moons, orbiting just inside Io's path, about 16 hours for one orbit. It's similar to Amalthea, irregular, dark, ancient. These inner moons are not ice worlds in the way Europa and the others are ice worlds. They're too close to Jupiter, too warm, or at least they were warm enough during their formation that ice couldn't accumulate. They're rocky, dusty, dark, more like asteroids than moons, though their origins are different. Their history's tied to Jupiter from the beginning. We're drifting back inward now, falling gently toward Jupiter, retracing our path through the system. The perspective shifts as we move, the distance is changing, the relative positions of the moons altering as they continue their orbits. Time has passed while we've been out here. Europa has moved in its orbit, Ganymede has shifted position, even Callisto has progressed along its slow path. The system is always in motion, never static, a dance that continues without pause. Jupiter grows larger again as we approach. The cloud bands resolve, the colors emerge, pale yellows and browns and whites, the darker belts and lighter zones stacked across the planet's face. The atmosphere here is deep, thousands of miles deep, pressures increasing with depth until eventually the hydrogen that makes up most of Jupiter's mass transitions from gas to liquid, and then deeper still to metallic hydrogen, a state of matter that doesn't exist naturally anywhere on Earth. The planet has no solid surface, no place you could land, just increasing density and pressure and temperature as you descend, until eventually the conditions become lethal, then impossible, then beyond anything we can easily imagine. At the very center, beneath all that hydrogen, there may be a core. Rock and ice, compressed to unimaginable densities, perhaps 10 or 20 times the mass of Earth, squeezed into a volume smaller than Earth itself. Or perhaps not. Perhaps Jupiter is hydrogen and helium all the way down, with no distinct core, just a gradual transition from gas to liquid to something stranger still. We don't know for certain. Jupiter keeps its secrets, hidden beneath layers of atmosphere and pressure and distance. The great red spot is below us now as we pass over Jupiter's southern hemisphere. The storm is enormous, 2 to 3 times the diameter of Earth, an anticyclonic vortex that has been observed for at least 350 years, possibly much longer. The winds at its edge blow at several hundred miles per hour. The storm rotates counterclockwise, once every 6 to 7 days, churning the atmosphere, mixing the cloud layers, creating the reddish-brown color that gives it its name. The exact cause of the color is uncertain, but it may involve complex organic molecules created by lightning or ultraviolet radiation acting on methane and ammonia in the upper atmosphere. The spot has been shrinking over the past century or so, getting smaller, more compact. Whether this is a temporary fluctuation or a sign that the storm is finally dissipating after centuries of existence, no one knows. Jupiter's atmosphere is complex, chaotic, driven by internal heat as much as by sunlight, and the long-term behavior of its storms is difficult to predict. But for now, the Great Red Spot persists, a feature larger than a planet, a storm that has outlasted empires and civilizations on Earth, a testament to the scales involved in planetary atmospheres. We're rising again, pulling away from Jupiter's cloud tops, climbing back into the orbital space where the moons circle. The planet falls away beneath us, still massive, still dominant, but receding. The curve of its limb is visible now, the edge where the illuminated day side meets the shadow of night, the terminator, though in a world without a solid surface the concept of day and night is strange, abstract, more about where the sun is in the sky than about any change in the landscape below. The 4 large moons are visible from here, all at once, arranged around Jupiter, their positions constantly changing as they move in their orbits. It's possible to watch them for hours, for days, and see the patterns emerge. Io disappearing behind Jupiter and re-emerging on the other side. Europa passing in front of Ganymede, one moon occulting the other. Callisto moving slowly along its distant path, barely seeming to shift position even over the course of a day. The orbital mechanics are precise, calculable, the same physics that governs planets around the sun, moons around planets, satellites around Earth. Gravity, inertia, conservation of angular momentum. Simple rules creating complex patterns, order emerging from the fundamental laws of nature. There's a sense of timelessness to this system. The moons have been orbiting Jupiter for billions of years since the solar system's formation, and they'll continue for billions more until the sun itself begins to die, swelling into a red giant, engulfing the inner planets, filling the sky with its bloated presence. Even then, even when the sun has changed beyond recognition, Jupiter and its moons will likely survive, pushed farther out perhaps, their orbits altered by the sun's mass loss, but still intact, still orbiting, still following the paths gravity has carved for them. The ice on these moons is ancient. Some of it may be as old as the solar system itself. Water molecules that condensed out of the protoplanetary disk 4.5 billion years ago froze, accumulated, became part of these worlds. Other ice is younger, formed from water vapor released by impacts or by cryovolcanism, water from the interiors brought to the surface and frozen there. But all of it is old by human standards, older than any structure on Earth, older than life, older than the continents, preserved in the cold of space, unchanging, patient. Water is common in the universe. Hydrogen is the most abundant element, oxygen is the third most abundant, and together they form water naturally whenever conditions allow. Much of the water in the solar system is locked up in these outer moons, in Jupiter's system, in Saturn's system, in the icy bodies of the Kuiper belt beyond Neptune. More water than all of Earth's oceans combined, frozen solid, scattered across the outer solar system in moons and comets and dwarf planets. Earth's water is a tiny fraction of the total, a small puddle on a small world, precious to us but unremarkable from a cosmic perspective. Yet it's that small puddle on Earth where water exists as a liquid on the surface, where it can pool and flow and cycle through the atmosphere, where it became the medium for life, the solvent in which chemistry became biology. The water on Europa and Ganymede is locked away, hidden beneath miles of ice, cut off from sunlight, from air, from the easy chemistry that happens when liquid water is exposed to energy and organic molecules. Life may exist there, but if it does, it's life of a different kind, adapted to darkness, to cold, to isolation, to conditions so alien to our experience that we can barely imagine what it might be like. The silence out here is profound. No sound can travel through vacuum, no vibration can propagate without air or water or some medium to carry it. Jupiter's storms are silent. The motion of the moons is silent. Even impacts, when they happen, are silent except to the material of the surface itself, vibrations traveling through ice and rock but never escaping into space, never becoming sound waves, just seismic energy propagating through solid matter until it dissipates into heat. If you could somehow float here, in space, between the moons, you would feel nothing. No air pressure. No temperature in the usual sense, just the balance between the heat your body radiates and the faint warmth from distant sunlight. You would see Jupiter, enormous and bright, filling part of the sky. You would see the moons, points of light or small disks depending on their distance. You would see the stars, steady and unblinking, no atmosphere to make them twinkle. And you would hear absolutely nothing. The silence would be total, complete, a kind of quiet that doesn't exist anywhere on Earth, not in the deepest caves, not in the most remote deserts, nowhere. The silence of space, the silence of vacuum, the absence of sound. But you wouldn't be floating here. No one floats here. This region belongs to radiation and vacuum and the slow patient orbits of moons that have been here since the beginning. We're visitors, observers, travelers in thought only. Our body is safe elsewhere while our attention drifts through this realm of ice and distance. The system is beautiful in its way. Not beautiful in the sense of landscapes on Earth, forests and mountains and oceans, but beautiful in the sense of structure, of pattern, of the mathematics made visible. The orbital resonances are beautiful. The tidal heating is beautiful. The fact that water exists as liquid beneath ice shelves light years from the easy warmth of Earth's surface, that's beautiful. It's the beauty of physics working exactly as it should, of nature following its own rules, of complexity emerging from simplicity. We're moving outward again now, away from Jupiter and its inner moons, into the space beyond Callisto's orbit. The system is receding, growing smaller, the individual moons becoming harder to distinguish. Soon they'll be just points of light again, for bright dots arranged around a brighter central point, the Galilean moons as Galileo first saw them through his telescope 415 years ago, a discovery that changed humanity's understanding of its place in the cosmos. Before Galileo, before those observations in 1610, People believed Earth was the center of everything, that all celestial bodies orbited around us. The moons of Jupiter proved otherwise. Here were objects clearly orbiting another planet, not Earth, demonstrating that Earth was not unique, not central, just one world among many. It was one of the first pieces of evidence that the Copernican model was correct, that the Sun, not Earth, was at the center of the solar system. A small observation for points of light changing position night after night, but its implications were enormous. Those 4 points of light are the same moons we've been exploring: Io, Europa, Ganymede, Callisto. They were worlds then, and they're worlds now, but we know so much more about them than Galileo ever could. We've sent spacecraft there, taken photographs, measured their magnetic fields, analyzed their surfaces with spectrometers. We've discovered their oceans, mapped their terrains, calculated their orbits to extraordinary precision. But they remain, in some fundamental way, mysterious. We know what they're made of, but we don't know if anything lives there. We know their surfaces, but we've never seen beneath them. We know their past, in broad strokes, but the details are still uncertain. Jupiter is smaller now, diminishing, still bright but no longer overwhelming. The Sun is brighter, closer, the dominant light source again as we move back toward the inner solar system. The moons are fading, blending with the stars, becoming part of the general scatter of lights across the darkness. The system is still there, still orbiting, still following its ancient patterns, but we're leaving it behind, drifting away, into the space between planets, into the emptiness that separates one world from the next. The distances in the solar system are vast. Jupiter is far from the Sun, but Saturn is farther, and Uranus farther still, and Neptune at the edge of what we consider the planetary system proper. Beyond Neptune are the objects of the Kuiper Belt, icy bodies in distant orbits, remnants of the solar system's formation. And beyond that, the Oort cloud, a hypothetical shell of comets surrounding the solar system at distances so great that the Sun's gravity is barely enough to hold them. And beyond that, the space between stars, light years of emptiness, distances that make the solar system seem crowded by comparison. But we're not going that far. We're just drifting, slowly, away from Jupiter, into the general dark. The moons are behind us now, Jupiter is behind us, the entire system receding into the distance. Ahead is nothing in particular. Just space. Just stars. Just the quiet continuation of the universe in all directions, indifferent to us, indifferent to Jupiter, indifferent to everything except the laws that govern it. The ice moons of Jupiter will continue their orbits. Europa will continue to flex and crack, its ocean hidden beneath miles of ice, its surface slowly renewed over millions of years. Ganymede will continue its slow rotation, its ancient dark terrain and younger bright terrain both preserved, both telling their separate stories of the moon's history. Callisto will continue to bear its scars, its craters accumulating slowly, its surface a record of impact stretching back to the beginning. And the smaller moons, inner and outer, will continue their own paths, fragments and captured bodies and primordial remnants all held in Jupiter's gravitational embrace. The system doesn't need observers. It doesn't require our attention. It was here long before we knew it existed, and it will be here long after we're gone, if we're ever gone, if humanity ever ceases to exist or moves beyond this solar system into the wider galaxy. The moons will orbit. Jupiter will rotate. The Sun will shine, growing slowly brighter over the next billion years, then swelling into a red giant in 5 billion more, then collapsing into a white dwarf, a dense ember slowly cooling over trillions of years until the universe itself grows dark. But that's so far in the future it's almost meaningless. For now, for the next billion years at least, the system is stable. The moons are safe. The ice is frozen. The oceans are hidden but present. The orbits continue, precise and predictable, a clockwork mechanism driven by gravity, sustained by the mass of Jupiter, regulated by the resonances between the moons themselves. We're far from Jupiter now. It's just another point of light in the sky, brighter than most stars but no longer obviously a planet, no longer showing a disk, just a bright. The moons are invisible from here, too small, too dim, lost in Jupiter's glare or scattered against the background stars. But they're there. We know they're there. Even when we can't see them, even when they're too far or too faint, they exist, they orbit, they endure. The darkness is complete again. We're back in the space between worlds, in the realm of distance and silence and the slow passage of time. There's nothing urgent here. Nothing demanding attention. Just the gentle awareness of our position, our trajectory, our slow drift through the void. Just the stars, steady and distant, marking out the constellations, the same patterns visible from Earth, from Jupiter, from anywhere in the solar system, only slightly shifted by perspective, only marginally changed by our position. The cold is absolute. Not cold in the sense of winter on Earth, but the cold of space itself, the baseline temperature of the universe, a few degrees above absolute zero, the heat left over from the Big Bang cooled by 14 billion years of expansion. Out here, away from stars, away from planets, that's the natural temperature. Everything radiates heat slowly into the void, cooling gradually, approaching equilibrium with the background, with the cosmic microwave background that fills all of space equally, a faint glow invisible to human eyes but detectable with the right instruments. But temperature doesn't mean much in vacuum. Without air to carry heat away, without conduction or convection, objects in space cool only by radiation, a slow process. A human body in space would lose heat gradually, over hours, not instantly. You wouldn't freeze immediately. You'd lose consciousness from lack of oxygen first, within seconds, your blood boiling in the low pressure, your lungs collapsing, death coming quickly but not from cold. The cold comes later, after death, as the body radiates its warmth into the void, slowly, over hours and days, until it reaches equilibrium with the background temperature of the universe. But these are just facts, details, the mechanics of vacuum and temperature and the human body's fragility. They don't matter here. We're not here physically. We're just drifting, observing, experiencing this realm in thought only, safe from the radiation and cold and vacuum, free to move where we like, to observe what we wish, to take our time. Time itself feels different out here. Without day and night, without the rhythms of Earth, without sunrise and sunset and the passage of hours marked by the sun's position in the sky, time becomes abstract. It still passes. Seconds tick by, minutes accumulate into hours, hours into days. But there's no external marker, no way to feel the passage except by watching the slow motion of celestial objects, planets moving in their orbits, moons circling their worlds, stars shifting their positions over months and years as Earth moves around the sun, carrying our perspective with it. But we're not on Earth now. We're out here, in the dark, drifting slowly through Jupiter's realm, or beyond it, or approaching it. The direction doesn't really matter. What matters is the quiet, the stillness, the sense of space extending infinitely in all directions, the sense that we could drift like this forever, that there's no hurry, no deadline, no destination that can't wait. Just the slow progression through the dark, just the gentle awareness of distance and silence and the patient continuity of the universe. The stars don't change. They're too far away for their motion to be visible on human timescales. The same constellations that ancient humans saw are the same ones visible now, will be the same ones visible for thousands of years to come. Individual stars do move, slowly, their proper motion carrying them across the sky, but the changes are so small, so gradual, that you need careful measurements over decades to see them. To the naked eye, the stars are fixed, eternal, unchanging. Only they're not. They're born and they die, fusion igniting and collapsing clouds of gas, stars shining for millions or billions of years depending on their mass, then exhausting their fuel, swelling into giants, exploding as supernovae or quietly fading into white dwarfs or collapsing into neutron stars or black holes. The life cycle of stars plays out over timescales that dwarf human comprehension, but it plays out nonetheless, the universe constantly recycling matter, creating new stars from the remnants of old ones, heavy elements forged in stellar cores and supernova explosions seeding new generations of planets and moons and, eventually, life. The ice on Jupiter's moons is made of those heavy elements. Hydrogen from the Big Bang, oxygen from ancient stars, combined into water, frozen, accumulated into worlds. Everything is recycled. Everything comes from somewhere else, was part of something else, will become part of something else in the future. The atoms in the ice on Europa were once part of a star, and before that part of the primordial hydrogen that filled the early universe, and someday, billions of years from now, they may be part of something else entirely, scattered by the sun's death throes, drifting through space, eventually captured by another star system, incorporated into new worlds, new oceans, new possibilities. The universe is patient. It doesn't hurry. It unfolds at its own pace, processes playing out over billions of years, structures forming and dissolving and reforming, matter and energy following the laws of physics, no exceptions, no shortcuts, just the steady working out of natural law across all of space and time. We're part of that. Human observers, consciousness arising from matter, minds contemplating the universe that created them. It's strange when you think about it. The universe is vast, mostly empty, mostly dark, and yet here in small pockets, on worlds where conditions are right, matter has organized itself into forms complex enough to think, to observe, to wonder. We're made of the same atoms as the ice on Europa, the same atoms as Jupiter's atmosphere, the same atoms as the stars themselves. We're not separate from the universe. We're part of it. A small part, a brief part, but part nonetheless. And now, in thought, we're drifting through the dark, far from Earth, far from home, experiencing the realm of Jupiter's moons in imagination, understanding something of their nature, their history, their place in the solar system. It's a gift, in a way. The ability to know things we can't directly experience, to understand places we've never been, to extend our awareness beyond the confines of our bodies, our world, our immediate surroundings. The darkness continues. The silence continues. The slow drift through space continues. There's no endpoint, no destination, just the ongoing experience of motion through the void, of distance, of quiet, of rest. This is a place for sleep, for dreams, for the mind to settle into stillness. The ice moons of Jupiter are behind us now, or ahead of us, or around us, it doesn't really matter. They exist, they orbit, they endure. And we drift on, slowly, gently, into the darkness, into the silence, into sleep.